You are viewing one of 10 modules developed through a project funded by Geoscience BC focused on direct-use geothermal resources in British Columbia. This follow-up project was carried out between August and December 2016. The project was executed by Tuyatera Geocorp. These modules were developed from the Direct-Use Geothermal Resources Roadmap published by Geoscience BC in June 2016. They incorporate additional educational material that were developed as part of the current follow-up project. The voices you will hear narrating the module are myself, Catherine Hickson, and my colleague, Juliana Proenza.
Hello, everyone. So we are currently on Module 5, which is Environmental Considerations. This module will go through some of the environmental benefits associated with direct-use geothermal applications, and then we will be going through some of the specifics in terms of environmental impacts that may be associated with direct use, particularly during drilling, installation of the mechanical system, what sort of things you have to worry about with respect to land use, emission levels, water consumption, subsidence, and noise levels. So in terms of the environmental benefits considerations when developing a project for direct use applications, essentially direct use applications typically have a positive environmental effect. Some of these different environmental variables include the reduction of consumption of fossil fuels when comparing it to conventional heating systems, the reduction of greenhouse gas emissions. Geo-exchange systems have been identified by Natural Resources Canada and the U.S. Environmental Protection Agency as the most environmentally benign space heating and cooling technology in terms of environmental impact. And most impacts that we'll be going through in this module can be mitigated and in some cases prevented altogether. So, depending on the size of the project, a formal environmental assessment may be required. Issues of noise, visual impacts, land use associated with drilling, and production operations are important but are typically fully manageable within the scope of the project. We'll be going through some of the statistics in terms of what the land and freshwater requirements are for geothermal direct use projects and how they compare to other technologies. And the activities that would typically require assessment include the drilling of geothermal wells, the construction of pipelines, transmission, and the mechanical systems. And of course, if you are not re-injecting the fluids, which is pretty rare at this day, you would have to assess the impact of disposing the fluids in another way. So this chart goes through some of the different environmental impacts associated with direct use and gives a rating in terms of the probability and severity of the potential environmental impact for direct use projects. We've got low, moderate, and high for the rating. And we've got impacts such as air quality pollution, surface water pollution, land subsidence, high noise levels, conflicts with cultural and archaeological features, and socioeconomic problems, and things such as chemical or thermal pollution and solid waste disposal. So you can see that generally the probability of most of these impacts occurring is low, with the exception of high noise levels, which can be mitigated in various ways. And then we've got the potential for surface water pollution if you are not re-injecting. And if you are re-injecting, then this probability goes down. And the conflicts for cultural and archaeological features, depending on where your project is, can be moderate. The probability of environmental impacts associated with solid waste disposal is moderate. But again, these impacts can be mitigated depending on the types of system components that you use. So if you are re-injecting, some of these impacts are further minimized, and generally, the impacts that are higher for conventional systems are already quite low for geothermal direct use application projects. So the early stage exploration for direct use projects has a minimal environmental impact. The real first perceptible effect on the environment is when you start drilling. And that's because the installation of a drilling rig and accessory equipment may require the construction of access roads and a drilling pad, which can vary in size depending on the size of the drill rig. And these operations do have the potential of modifying the surface morphology, and some of these things would require remediation after the project has completed drilling. Blowouts, which is really something that you have to worry about more when you're dealing with higher temperatures, and the probability of this decreases considerably if you are using blowout preventers. But essentially, the potential impact there is that you can pollute surface water with the drilling fluids coming out of the well. But again, typically blowouts are only a concern when you're dealing with high temperatures and pressures of fluids coming through that depth. And during drilling or flow tests, there may be undesirable gases that may be discharged into the atmosphere, but typically this period of time is quite short, and there are some tools that you can use in order to mitigate the discharge of these gases. And once the drilling is completed, the impact on the environment that is caused by drilling typically ends. So that's definitely something to keep in mind, that it is a short-term impact, and with mitigation and some prevention, these impacts are minimized. Once drilling is complete and you're moving forward with a project, there are different components that need to be installed, such as pipelines and utilization plants. And what this really does is essentially distribute the flow of water to the different end-use applications. And so again, here you've got potential impacts that will affect the surface morphology of the terrain, possible wildlife and plant life impacts, and a lot of this can be minimized depending on where the pipeline goes through, and there are some examples globally where this impact is really quite low and negligible. In some cases, the visual component of these systems have been used positively by having art on the pipelines that educate the public with respects to what direct use and geothermal is. So there are ways to minimize that impact. So here we've got a chart of a 30-year land use comparison using power plants as analogous to direct use plants. So we're comparing coal, solar thermal, photovoltaics, wind, and geothermal. So you can see here geothermal by far has the lowest land use requirements for a plant, whether or not it's a power or direct use plant. The difference is quite small. So this is essentially showing you is that the land that is going to be disturbed by the process of exploration, development, and final plant commissioning is quite low when comparing it to alternative technologies and conventional technologies, such as coal. Now, Kathy went through some of the geochemistry associated with exploration, and so depending on the geochemistry of the geothermal fluid and whether it is being used in an open or a closed system that is re-injected, some of these gases do contain things such as CO2, hydrogen sulfide, ammonia, methane, and other types of chemicals that, if discharged into the environment, can pose an environmental impact on the surroundings. So if you are re-injecting, this is not an issue at all. The system is closed. Whatever you're pumping up is being pumped back down into the ground. And generally, these issues are even less of a problem with fluids that are at a lower temperature, which is less than 80 degrees. And in most cases for direct use applications and the focus of our project, these temperatures would be lower than 80 degrees. And so the geochemistry of the fluid wouldn't be as aggressive in order to pose this risk if an open system was being used. So what you've got here is a chart that is essentially showing you the different chemicals that we're looking at, and then comparing different types of geothermal plants with a couple of conventional systems, natural gas and coal. And the binary plant is being used as an analogy to direct use because it is a closed system and the fluids that are coming up from the ground are not being expelled into the atmosphere in a binary plant, which would be the same case for direct use plants that are using reinjection. So in terms of water consumption, the amount of water used in geothermal processes varies on a few different things. It varies on the type of resource that is being developed, the type of plant that is being built for the development, and then the type of reinjection that you're doing. So again, direct use is most analogous to a binary power plant. And so what you've got here in this chart is comparing different types of power plants, conventional and alternative technologies, and then the total cycle water consumption requirements. And you've got geothermal binary plant on the, on the very lower end of the spectrum, which is the second lowest requirements after solar photovoltaic, and then the third one is biomass. And then you can see that the conventional systems are on the higher end of the spectrum. So some of the environmental impacts that you have to take into consideration include things like subsidence and microseismicity. So when you're extracting large quantities of fluids from geothermal reservoirs, this may result in subsidence, which essentially is just a gradual sinking of the land surface. This isn't typically a catastrophic process. It is a slow process and is distributed over a vast area and happens over a long period of time. Typically, there are ways to measure subsidence, and it can be prevented or reduced by the reinjection of geothermal wastewaters. And what that does is it maintains the pressure of the system and really minimizes the impact of subsidence. Now, the withdrawal of geothermal fluids or reinjection of geothermal fluids may trigger or increase the frequency of microseismic events in certain areas. There have been some concerns in the past with systems that are being stimulated, and so basically in those systems, what's happening is a large amount of water is being injected into the ground at depth at huge amounts of pressure. And that is different than what we're doing here. In those systems, that stimulation is done in order to fracture the rock in order to stimulate a geothermal reservoir and increase the permeability and the productivity of a geothermal reservoir. And that type of system is still in the demonstration stage. Here we're talking about really microseismic events that are occurring all the time, and so you may trigger a microseismic event or increase their frequency, but these events really are only detected through specialized instrumentation, and the exploitation of a direct-use geothermal resource is unlikely to trigger a major seismic event at all. That probability is very low. So that's definitely something to keep in mind. We're including it here for completion, but it's not a high-risk environmental impact. Now, we've talked a little bit about noise levels and how it's one of the higher probability environmental impacts. Most of the high level activity happens during drilling, and then once drilling is complete, the noise generated in direct heat applications is usually negligible. So during drilling, noise levels can be minimized by things such as temporary noise shields, for example, which are just temporary structures that are put up around a drill and can really help minimize the noise that way. And in terms of an actual plant, noise levels are really only a problem where the plant is also generating electricity. So if you've got a combined heat and power plant, at the power plant, the main noise pollution comes from the cooling tower fans and the steam injector and the turbine hum. And some of the ways that you can mitigate that is by having well-insulated buildings with noise-absorptive interior walls, and these things can minimize that turbine noise. So those are the majority of the environmental impacts that you need to consider when exploring for and developing a direct use geothermal project. And as you can see, comparing it to other alternative technologies and conventional systems, for the most part, the environmental considerations for geothermal direct use are on the low end of the spectrum. And there are benefits that have been acknowledged for developing direct use projects.